Hi, everybody. I'm Chris Preimesberger, editor of eWEEK.com. Thank you very much for joining us today in this latest segment of eWEEK eSpeaks. It's a series of informal conversations with IT thought leaders from every corner of the business. Our interviewee today is Tony Uttley. Tony is the president of Honeywell Quantum Solutions, and you're based in the great state of Minnesota. Welcome, Tony.
Thank you. It's wonderful to be here. Appreciate it.
Yeah, I have a certain love for Minnesota, where a lot of my relatives are from, and I enjoy visiting back there whenever I can. And great growing place for IT also. It's a real center now, I think, of the future for IT, and of a lot of developers being able to work from anywhere. I think they can choose where they want to live, and and the Twin Cities is a great family place to live.
It also turns out if you want to cryogenically cool something, it helps if you start in a cold place.
Yeah, that's right. I can tell from your accent too. That's where you're from. Okay. So Tony, tell me a little bit about what you do. I mean, being the president of it, obviously the top administrator, but tell me a little bit about Honeywell at the high level and about quantum solutions.
Yeah, it's interesting because I think a conversation I frequently have is, why is Honeywell in quantum computing? And that tends to be predicated on two things. One is most people don't know what Honeywell does, and then most people don't know what a quantum computer looks like. And if they knew both of those two things, they would actually say it absolutely makes perfect sense that Honeywell. So what Honeywell does across a breadth of what we call strategic business groups, so businesses within Honeywell, are things like control systems for running giant petrochemical plants, or building control systems and security enterprises for things like university campuses. We help do warehouse automation. We provide personal protective equipment like face masks that have been used in this pandemic around the world. We do edge device artificial intelligence, so congregating those edge devices that exist, whether it's a building controller or something that would be on a factory line, to be able to then take real-time action as a business to be able to get productivity. And there's a centerpiece that kind of translates across all of those different elements of Honeywell, and it is, we are controls experts. And it turns out that quantum computing is a controls problem. And if you look across our aerospace business and our performance materials and technologies business, which is where we make chemicals, part of what translates is things like cryogenic systems, where we do ultra cold work, magnetic field manipulation, photonics, lasers, precision, ultra high precision controllers, vacuum systems. And it turns out if you put all those things together, you can actually build a quantum computer.
Oh, really? Interesting. That's cool. How would you can you just define quantum computing for me real quickly, and for some of our readers who may not really know what that means?
Sure. Again, a great question I hear all the time. I'll say what it's not. And this is the most common, probably, misunderstanding, is that people think of a quantum computer as a faster classical computer. It's not that. It can be much faster at doing jobs, but that's because it operates very differently. And some of the key pieces of why it operates differently are foundationally based on quantum mechanics, quantum physics. So what are some of those things? One of them is something called superposition. So this is where, if you are in a classical computer and you have a bit, that bit is either a 0 or a 1. And if you're in a quantum computer, that bit, that quantum bit, so qubit, can be both a 1 and a 0 at the same time. And what's incredible, will kind of blow your mind, is it can also be anything in between a 0 and a 1 at the same time. So that is the power of superposition. Then there is something called entanglement, and that is, you can get two qubits to interact, and that interaction will have a continued correlation despite the fact that you've moved them physically, either through space or through time. They will stay connected. And that entanglement allows you to do certain types of computations that just can't be done with classical computers today. And then there's a fabulous third part of this, which is when you're doing a computation within a quantum computer, it's all about how you define the algorithm, how you've just think about it as the software that's being used on that quantum computer. And there's again a quantum physics property that allows you to look at all of the answers, and if you've set up your algorithm correctly, the wrong answers drop out and you're only left with the correct answers. When you take that triumvirate of superposition, of entanglement, and then this third piece, it allows you to take advantage of what quantum computing can then do really well, which is certain classes of problem. So you're not going to use a quantum computer to do your Excel. You may very well use a quantum computer to help simulate the molecular structure of a new molecule. And then how that molecule could interact with other molecules. And the fabulous part of this is we are just at the very beginning of what is going to be a long-term evolution of quantum computing.
Yeah, that's great. I always thought of qubits as being a measurement involved in Noah's Ark, from the Bible, but I understand now that it's more than that. And you're absolutely right. We're on just the front step of this new computing and harnessing it to use more and more in use cases. So that's great stuff. Thanks for defining that for us, Tony, because you can read that in a book or you can look it up in Google, but it's better to have someone explain it to you. So I appreciate that. How is quantum actually going to be used in real business scenarios? Because, eWEEK is really involved in, part of our message is to explain how this new gen tech is going to be used in the real world. And you mentioned a little bit. Can you go a little deeper on that?
Absolutely. I mean, part of it starts with, again, why is Honeywell involved in quantum computing? And as I mentioned earlier, Honeywell's in the aerospace business, and we're in the molecule development business, the chemicals business. We're in the optimization business, and each of those areas are going to be profoundly impacted by quantum computing. And if you think about what quantum computing does differently, and then how you can apply that in either a business sense or what you're going to see in your life, are things like really hard optimization problems. So it actually doesn't take very many variables in an optimization problem before you get to the point where it is intractable with a classical computer. It just absolutely can't be done.
Right.
And people tend not to think about it because we know the classical computers that exist today are so powerful and they do certain things extremely well. But once you run into enough variables, you get enough different solutions that are trying to all be contemplated at the same time that you basically just run out of space within the computation, because the classical computer is trying to do all this serially. And what quantum computers can do is look at that solution space basically simultaneously. So if you think about when I said a qubit can be in both a 1 state and a 0 state at the same time, that means that you have, well, I'll do a little bit of math for you here, 2 to the power of n, where n would be the number of qubits. And so if you have 10 qubits, 2 to the power of n would be just over 1,000 different values that are being considered. When you jump from 10 to 50, you now have 1.1 quadrillion values that would be considered the same problem set. And that exponential increase that allows you to tackle problems that are today intractable. And those could be anywhere from trying to think about climate change to trying to develop new life-saving pharmaceuticals to really route optimization problems that can help do things like get food from places in the world where it exists in abundance to places in the world where it does not. So these are going to be profound humanity impacting outcomes that we're going to ultimately get from quantum computers.
Right. So I guess we could probably boil it down, because that's what I do. It's my job is to boil it down into language and that we can understand. Quantum computing is big math and big computations for big results. How's that?
That's fabulous.
That's my headline. So I've written my headline. I can quit for the day. I'm done. No. No, great, Tony. Thanks for that. Again, I appreciate that. What's next for Honeywell Quantum and the industry as a whole? And looking ahead, like we said, this is just the beginning. We're kind of at the pioneering stage of all this. But what do you foresee for the next year to 3 years out, maybe 5 years out, that we should know about?
Sure. I'll start with something that, again, probably most people don't know, which is I talk about quantum computing in 3 eras. There's this emergent era, and that's what we're in right now. And it's a very profound era. It is where quantum computers didn't exist, and now they exist. Big moment, right? Yeah. There's a third era, so I'm going to skip one, obviously, come back. There's a third area, which is this classically impossible. These are the computations that are going to be done that you couldn't in 1,000 years or 10,000 years of running the highest performing supercomputer on the planet do the same computation that you could do with this quantum computer. Mm-hmm. And that will happen. But then there's this middle era, and the middle era is classically impractical, which means you could have done it, but you don't. And you don't either because it takes too long. Maybe the classical computer would take a month to come out with an answer, and you can't wait a month to get the answer, or because it costs too much, or like we're finding out today, some of the computations that happen around the world consume massive amounts of power, like really energy-intensive computations. And so this emergent era is one where you actually can do the same computation, or at least you can simulate the computation using a classical computer and perform it on a quantum computer. Mm-hmm. Get the same answer. So one might ask, why does anyone do that then? And it is because the period of time for which you're going to be able to, let's call it fact check the quantum computer with a classical computer, is going to be a tiny little sliver of time. And so what we are using it right now with our customers, with our partners, is it's about building trust. Mm-hmm. Because at some point, and that point is not very far away, we're thinking something on the order of 18 to 24 months, we're going to pass that point where you're going to be able to classically simulate the answer. And when you pass that point, you better have built up that trust that your quantum computer is going to get to the right answer.
All right. Wow. Thanks for explaining that. That's great. I've heard that Bitcoin computations take lots of power. The cryptocurrency of all kinds takes lots of power. That's kind of a negative when it comes to that. But eventually, maybe those will be speeded up by quantum, you think, or not? Or are they already using quantum?
They're not currently implementing quantum as a part of their process, but they are certainly, many of them are experimenting with quantum as a use case to be able to do that for exactly the reason you suggest, which is mm-hmm. part of that chain that Bitcoin relies on is a proof of work. There's enough effort that has to go into the computation that it actually provides for that trusted handoff. But a number of cryptocurrencies and kind of financial services in general are looking at quantum computing as a way to be able to do optimization much more efficiently, much more effectively.
Yeah. All right, Tony, we're just about at the end of our time here today. I really appreciate your time with us. You've explained some very difficult concepts very well. Thank you.
My pleasure.
And glad to hear about what Honeywell's doing. We'll keep a close eye out on this company. I think it's, in some ways, it's really being reborn, hasn't it? Kind of reinventing itself from its long history of industrial IT. It's managed data and power very well for years, and now you're going into some other areas which are really exciting. That's good.
Yeah, we absolutely think of ourselves as the premier software industrial.
I can understand that. Tony Uttley, thank you very much. President of Honeywell's Quantum Solutions Group. Thank you very much. I appreciate it.
My pleasure.
And for everybody following along to the end of the eWEEK's eSpeaks today, thank you very much. Have a great rest of your eWEEK. Thanks for joining us on eWEEK eSpeaks. Go to eWEEK.com to hear more conversations with IT thought leaders.